Today we will be talking about unit vectors. What is a unit vector? Well, a unit vector is used to represent vectors conveniently, but technically a unit vector, a unit vector has a magnitude of 1 and it is dimensionless. So what is the purpose of a unit vector? The sole purpose of the unit vector is to describe a direction in space. Usually we write a unit vector with a caret, or what we say, a hat symbol. Okay, a hat symbol. So suppose we have vector A, which is, let's say, 7 meters along the x-axis, along the positive x-axis. Okay. So how are we going to write this vector A in terms of the unit vector? Well, we could write it as A vector is equivalent to the magnitude of A, and we will multiply that on which axis vector A is plotted. So in this case it is plotted along the x-axis, so we will write it as x hat. No? So to prove that the unit vector x hat has a magnitude of 1 and it's dimensionless, we could use this expression that vector A divided by the magnitude of vector A. So that would give us 7 meters along x-axis and we divide that with the magnitude, which is also just 7 meters. So pretty much it says straightforward that it is just 1 unit along the positive x axis, which proves our definition. So if we will plot this on a three-dimensional Cartesian plane, vector A would be something like this. Okay, this is a rough sketch. Okay, the drawing is not to scale, so that would be vector A. So where will be the unit vector, or where is the unit vector here? So the unit vector is here, just 1 unit along the x-axis, which is x hat. Okay, for the x-axis we use x hat, for the y-axis we use y hat, for z hat. Okay, now there are other books or references that uses other notations. For example, instead of using x hat, what they do they note x hat as I hat. For y-axis, they use j hat, and for the z-axis, they use k hat. Okay, but nonetheless, they convey the same meaning. Okay, now there are also other notations available for this. Okay, now why do we have to use unit vectors? Well, unit vectors can easily point our vectors in space without the without the problem of adjusting the angles, just like when we were dealing with the Cartesian coordinate type, no, when we do vectors. Okay, so generally speaking, we can express vectors in three-dimensional space. Just to give you a glimpse, if we have a position vector r, we can represent r in three dimension using the unit vector form. So that will give us rx x hat plus ry y hat plus rz z hat. Okay, but for now we would be confining ourselves to two-dimensional coordinate system. Okay, so the first thing that we have to be familiar with is how can we convert the Cartesian coordinate vectors into unit vectors. So suppose we have vector A, and vector A has the following magnitude of suppose 5 kilometers, and it is directed 30 degrees north of east. So how are we going to convert vector A into its unit vector form? But first, in order for us to better understand, we have to plot vector A. Okay, so this is again a rough sketch. So suppose this is vector A. So we can say that this is the angle, this is the placement of the angle, this is 30 degrees, and the components of vector A, this would be AY, and this being would be AX, right? So from what we have learned from the component method, or getting the components of vector, we could say that AX is actually equivalent to the product of the magnitude of A multiplied by cosine 30 degrees, in which case this is 5 kilometers, and cosine 30 degrees would give us square root of 3 over 2. Therefore AX is equivalent to 5 or 5 halves square root of 3 kilometers. Now for AY, that would give us the magnitude of A, and then sine 30 degrees, so that would still be 5, and sine 30 degrees is 1/2, so AY would give us 5/2 kilometer. So how can we now use this information to convert our Cartesian vector into a unit vector? From our definition earlier, we could say that vector A is actually the sum of AX along X hat and AY along Y hat. So we could use this knowledge, and we could just easily plug in the values of AX and AY. So we have A equivalent to 5 square root of 3 over 2 X hat plus 5 over 2 Y hat. I'll place the units here, and as you can see, we can factor out the common, which is 5/2, so we can write A, or vector A, in its unit vector form finally as 5 over 2 multiplied by square root of 3 X hat plus Y hat. So this is now the unit vector form of our previously Cartesian vector. Okay, I hope this is clear. Now let's get the reverse process of this one. What do we mean the reverse process? Suppose we want to express now the unit vectors, or the unit vector, into Cartesian. Well, suppose we have again here vector B, and let's say vector B is 3 X hat plus 4 Y hat, which is in meters. Okay, and we want to convert this into the Cartesian coordinate form of vectors. So to better understand this, let's plot. Okay, so we can say from the given that the X component is actually 3 meters along the positive X axis, and the Y component is actually 4 meters along the Y axis. So given the components, again a rough representation. Okay, so this is going to be, I failed to do a straight line. Hopefully this will be straight. Okay, so this will be BX, and another rough estimate, this is going to be BY. So our vector B would be this one. Okay, so how can we get now how can we express now this into the Cartesian? So to get the magnitude of B, we will use the idea from Pythagorean, that would be the square of X, the square of Y, under the square root sign. So this would give us 3 squared plus 4 squared. Okay, so that would be 9 and 16 added together, under the square root sign. So the magnitude of B is actually 5 meters. Okay, so we now have the magnitude. The next thing that we have to do now is to get the angle, because the angle would actually give us the direction. So to get the angle, we use the formula theta equals to arctangent, and that would be by over bx. So arctangent of 4/3, so approximately theta is 53 degrees. Okay, 53 degrees with respect to the positive x-axis. Okay, because the usual rotation would be from the x-axis would be 0, and then you go counterclockwise for the positive orientation of the angle. So therefore, to express that vector, no, to express this unit vector into a Cartesian form, we have vector B to have a magnitude of 5 meters and a direction of 53 degrees north of east. Okay, so I do hope that you've learned from this video on how to convert vectors from other forms.